Well, hello everybody. What I need to do with you today is I need to review our sequence and series unit that we've been working on this last week and a half. What you'll need in front of you, you should have a Day 5 class review first. What I'm going to do on that Day 5 class review, guys, I'm going to go through numbers 1, 4, 7, 8, 9, 14, and 16. And then what I'm going to ask you to do is pause the video and then finish the ones that I didn't get to. That should be a good review for you. I would like to quiz you today on arithmetic sequences and series. That'll be the front of that review sheet. But we'll do that towards the end of the hour. Now, you should also have in front of you, as soon as you're done there, you need what's called the Day Class 6 class examples. So Day 6 class examples. It's nothing new. It's review of what we've done the last few days, but we're going to mix them up. So you will have to identify it as either arithmetic or geometric, and you'll have to identify it as a sequence or a series. And of course, there's an assignment afterwards. So if you would come over to your class example sheet that says from worksheet number 1, arithmetic sequences, what I'm going to do is review each formula that we've done. So given the sequence that goes 3, 7, 11, and 15, we know it's arithmetic because that's what the direction said. We also know it's arithmetic because my D value is 4. I'm adding 4 every time. So now you're going to look at your note card and you're going to use this formula right here. The one that says A sub n equal A sub 1 plus D n minus 1. And then now you're just going to sub in these values. A sub n equal A sub 1 is 3. My D value is 4. And then there's always n minus 1 there. We will now distribute the 4. So I've got 3 plus 4n minus 4. Combine your like terms. So I've got 4n minus 1. Now here's my formula. Now, let's check it before we move on, though. To check it, I'm going to plug in a 1 and a 2. I'm going to go 4 times 1 minus 1, and I better get 3. And then I'm going to go 4 times 2 minus 1, and I better get 7. If we don't, we messed up, and we need to go back and find our error. But in this case, it works. So another little thing I want you to notice that it has to have an A sub n in front of it. That way it's a formula. Now for part B, to find A sub 25, I'm just going to plug 25 into that formula in place of n. So I've got 4 times 25 minus 1, so that term happens to be 99. So there's number 1. The next one I wanted to do with you was number 4. So I feel that you can do number 2 and number 3. Number 4, use the formula S of n equal n over 2, A sub 1 plus A sub n to find the indicated sum. That's that little formula by Carl Gauss. So to do this, I'm going to start off with, I'm going to have 50 divided by 2. I got that 50 from right there. Now, I need to figure out A sub 1, the value of the first term, and I need to figure out A sub 50. Well, to figure out A sub 1, I'm going to plug in 1. So A sub 1 is 3 times 1 minus 10, which gives me negative 7. So negative 7 is going to go right there. A sub 50 is 3 times 50 minus 10, which is 140. So the 140 goes right there. Now guys, in terms of your calculator, let your calculator do this work. I'm going to go 50 divided by 2, parenthesis, negative 7 plus 140. Close that off, enter, let your calculator do the work for you. This answer looks like 3,325. So there's our formula for arithmetic series. The next one I'd like to do with you is your number 7. Find the sum of the first 75 terms that goes 100 plus 985 plus 970 on down the road. Well, one thing I noticed, this is arithmetic because I am subtracting 15 each time. If you go 1,000 minus 985, you'll see where I got the 15, and we're subtracting it. Now, before we can do this, I need to figure out the 75th term. So step number 1, I need to use a sub n equal a sub 1 minus 15 n minus 1. I'm going to simplify this formula, so I've got 1,000 minus 15n plus 15. I just distributed. So I get my formula to be negative 15n plus 1,015. The reason I need that formula is that formula we just used, the arithmetic series, it only works if it's written like this. So I need to sum up the first 75 terms of the sequence that goes negative 15n plus 1,015. Now to get my answer, 75 divided by 2. I need to plug in 1 to get the first term. Negative 15 times 1 is negative 15 plus 1015 is 1,000. I also need to find the 75th term. So negative 15 times 75 plus 1015. That comes out to be negative 110. That goes right there. Run this part through your calculator, and you should get 33,375. So I call these the money problems. If you do not know your formula, we got to find that first, and we got to do that so we can find the 75th term. So that's number 7 on your sheet. You'll use these exact same steps on your number 6. The next one I'd like to do with you is your number 8. Now my number 8 says write out the first 4 terms of the sequence that's represented by g sub 1 equal 3 and r equal 2. It's important that you recognize the g and the r. The g tells me it's geometric. The r tells you that I'm multiplying by 2 every time. So I'm going to write down 3 for my first one. And then after I wrote down 3, my r value is 2, so we're going to multiply by 2 every time. Now be careful on these. If you would have seen d instead of r, you would have added 2 instead of multiplied. So that's what your number 8 is going to look like. Here's what your number 9 looks like. Find a formula, and then find the 10th term of the sequence that goes 2, 6, 18. Now when I look at this, notice that I'm multiplying by 3 every time. That makes it geometric. Now I'm going to look at my note card. My formula for geometric sequence is g sub n equal g sub 1 r n minus 1. Like it when geometric shows up, because all you need to do is plug in your g sub 1, which happens to be 2, plug in your r value, which happens to be 3, and then place your n minus 1. Remember, if you ever can't look at it and get your r value, take your second term divided by your first term, and that'll give you your r value every time. So there's the first piece of it. Now the second piece of it, to generate the 10th term, 2 parentheses 3 to the 10 minus 1 is 9, and we're just going to run that through your calculator. So I'm going to go 2 parentheses 3 to the 9th, and it looks like I get 39,366. Looks like the next one I'd like to do with you is number 14 on your worksheet. Guys, remember when you see the word expand, that means you're going to show the terms that you're adding up. Now, I gave you a shortcut this year on how to do this. I'm going to add up the first 8 terms generated by 2 to the x. So you're going to come into your calculator. You're going to go to y equal, and you're going to hit 2 caret x. you're going to go second table, and you're going to make sure your 1's at the very top. So things that I know, my first term is 2, my second term is 4, my third term is 8, my fourth term is 16, and I'm going to do that until I get up to 8. So I'm going to write those terms down if I can remember them. This happened to be a 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 plus 256. Term number 1 through 8. Now we're just going to grab our calculator and add those terms up. So we're going to get 510. So if you see the word expand, that's your cue to grab your graphing calculator, type that in, and list your terms. The next one I'd like to do with you is your number 16. Find the sum of the first 10 terms that goes 2 plus 6 plus 18. Well, what I've got going on this is geometric because I'm multiplying by 3 every time, so my R value is 3, and it's a series. So I'm going to go to my geometric series formula, which looks like this. G sub n is G sub 1 times R to the nth minus 1 over R minus 1. So G sub 1 happens to be 2. My R value happens to be 3 to the 10th power, not 9, minus 1 over parenthesis 3 minus 1. Now, remember when we're typing this in, I'm going to get out of this 2 parenthesis 3 caret 10. Use your right arrow to get out of that, minus 1, divided by another parenthesis, 3 minus 1, unless you do that part in your head. Once you hit enter, that should sum up those terms for you. So 59,048 happened to be that term. So there's what I've got so far for you. What I'd like for you to do now is pause the video and then do the ones that I did not do. And that'll give you some review. Now, on an upcoming slide, I have the answers that you should have had. So pause the video. You're welcome to pull up next to a friend and then see what kind of damage you could do. So hopefully you've already paused the video. Guys, on this next slide here, those should be the solutions that you've had. So pause the video if you need more time to look those over. Otherwise, what you need in front of you now is you need your Day 6 class examples. Where we're going to go next is this. You're going to be given a sequence and or a series. You have to decide if it's arithmetic or geometric, and then apply the correct formula. So have your Day 6 class examples right in front of you, and then we'll go from there. Now, so here's your number 1. Look at the sequence before I start. Now, I've thrown around the word sequence and I've thrown around the word series. Sequence, separated by commas. Series, separated by addition signs. In this case, they're separated by commas, so this makes it a sequence. Looking at your terms, I'm adding 4 every time. So that makes it an arithmetic sequence. Well, since it's an arithmetic sequence, you're going to look on your note card. You're going to grab the arithmetic sequence formula, which looks like this. A sub n equal a sub 1 plus dn minus 1. Sub in 5 for a sub 1, 4 for your d, and then the n minus 1 is always there. When I distribute, I've got 4n minus 4. So my formula is going to look like this. I need that a sub n, otherwise it's not a formula. 4n plus 1. I simplified the 5 and the negative 4. Now, do not miss these. Plug in 1 and plug in 2. 4 times 1 plus 1 is 5. 4 times 2 plus 1 is 9. Those better be the first two terms of your sequence. If they're not, you messed up. Now, for the second part, I'd like to find the value of the 15th term. Well, we're just going to go 4 times 15 plus 1. Run that through your calculator. Going to get 61 to be the 15th term. Here's your number 2. Look at the sequence. I know it's a sequence because it's separated by commas again. From term to term to term, it looks like I'm multiplying by 4. That means my R value is 4. Remember the other way to get your R value? Your second term divided by your first term. Be happy when it's geometric because your formulas can't be simplified. I'm going to have G sub n equal G sub 1, which is 3, in parentheses the R value, which is 4, to the n minus 1. Once again, you got to have the G sub n, you got to have the n minus 1. Now to find the value of the 15th term, I'm going to run through my calculator. 3 times 4 to the 15 minus 1, which is 14. Now, this is going to be a big number. So I'm going to have 3 parentheses 4, caret 14, enter. So there's the number that you should get. So looks like my teaching salary, $805,306,368. Moving on. So looking at my number 3, this one's a tricky one. I'm going to assume for just a second that it's arithmetic. To go from 100 to 162, I'm going to minus 18. I got that because I went 180 minus 162 and told me 18. Notice if I subtract 18 again, I'm not going to get 145.8. So this thing cannot be arithmetic. It must be geometric. Now let's get our R value. My R value is going to be 162 divided by 180, which is 0.9. Now, since it's geometric, nice. G sub n equal 180. My ratio, which is 0.9, to the n minus 1. There's your formula to find the value of the 15th term. In my calculator, I'm going to run through 180.9 to the 14th power. So we'll type that straight in, and I'm going to round, so notice the approximately signs, 41.18. So geometrics are nice. You don't have to simplify them. Here's my number 4. Look at it, decide if you can decide what it is. To C, I'm going to go 109 minus 89, and I'm going to get 13, so we must have subtracted 13. 89 minus 76 is also 13, so that makes this arithmetic. Now, on the arithmetic, we got a little bit of work to do now. So I'm going to say A sub n equal 102 minus 13 n minus 1. Minus 13 because we are decreasing. So I've got 102 minus 13n plus 13. Notice a negative and a negative made a positive. So my formula becomes negative 13n plus 115. Now, once again, check it, guys. Negative 13 times 1 plus 115 better give me 102. And negative 13 times 2 plus 115 better give me 89. If it doesn't, you messed up, and you're also going to miss the next piece. So the value of this 15th term, I'm going to go negative 13 times 15 plus 115. Run that through your calculator. You should get negative 80. Now, on my next little group here, all of these are going to be series. We're only going to do 4 problems. All of these will be series. We just have to decide if it's arithmetic or geometric. If it's geometric, we're going to go straight to this formula, the g sub 1 r to the n minus 1 over r minus 1. If it's arithmetic, first we got to use this formula to get the formula that generates it, and then I'm going to use this formula from little Carl Gauss. So there's going to be our steps. So we're going to look at this one, decide if you think it's arithmetic or geometric. I'm going to assume for a minute it's arithmetic. To go from 200 to 150, there's minus 50. If I minus 50 again, I'm not at negative 112. So this thing is not arithmetic. It must be geometric. In this case then, I'm going to have the sum of these terms is going to be g sub 1, which is 200, parenthesis. My ratio, whatever it takes to go from 200 to 150, well, can't just look at it, so let's go get it. 150 divided by 200 tells me that my ratio is 0.75. So I'm going to go 0.75 to the 15th power minus 1 over parenthesis 0.75 minus 1. Remember, the parentheses are very important. So when I type this in, I've got 200 parenthesis 0.75 caret 15. Hit your right arrow to get out of the exponent, minus 1 parenthesis divided by parenthesis 0.75 minus 1. Hit enter, and there's your number. Now, since we are rounding this to 789.31, we usually round to the nearest hundredth, make sure you put approximately 789.31. Here goes our number 5. The sequence itself goes 5 plus 12 plus 19. Looking at it, it looks like it's arithmetic because I'm adding 7 every time. Along the way, guys, we need to know what a sub 1 is and what a sub 50 is. In this case, I don't know a sub 50, so we need to first get my formula. So I'm going to go a sub n equal 5 plus 7 n minus 1, 5 plus 7n minus 7. So it looks like my formula is 7n minus 2. Now these are my money problems, so do not miss it. Plug in 1, plug in 2. Make sure you get 5 and 12 for your first 2 terms. Now, we're going to write it like this. The Greek letter sigma of 7n minus 2 from n equal 1 to 50. Now, this is your cue to use this formula, the n over 2 a sub 1 plus a sub n formula, to get the sum. So in this case, I'm going to have 50 over 2. I need to plug in 1 to get the first term. So 7 times 1 minus 2 is 5. 7 times 50 minus 2 tells me this is 348. Now we're going to run this through our calculator. And if you do that correctly, you should come up with 8,825. Now, these are one of those problems I refer to as my money problem. When I grade, I have to give you points for this formula. I have to give you points for this 348. I have to give you points for that total. So don't just stop at the 348. Make sure you bring it home. Next to the last one, my sequence goes 10, 10.5, 11, 11.5. In this case, it's arithmetic because I'm adding 0.5 every time. Since I do not have the formula, let's go get it. a sub n equal 10 plus 0.5 n minus 1. I've now got 10 plus 0.5 n minus 0.5. So my formula looks like 0.5 n plus 9.5. Of course, plug in 1 and plug in 2 to make sure you're right. This now becomes Greek letter sigma from n equal 1 to 100 of 0.5 n plus 9.5. Now let's go get it. We've got 100 divided by 2. I need a sub 1, so I'm going to plug 1 into here. 0.5 times 1 plus 9.5 is 10. I also need a sub 100. So I'm going to go 0.5 times 100 plus 9.5, and I'm going to get 59.5. We'll run that through our calculator. If you're with me or a little bit ahead of me, you should have got 3,475. My last one, my number 8. My sequence itself, my series itself goes 8 plus 12 plus 18 plus 27. Decide if it's arithmetic or geometric. So plus 4 plus 6 plus 9, so it's definitely not arithmetic. It's got to be geometric. So I'm going to look at my note card. My formula for geometric series goes, the sum of these numbers is g sub 1 r to the n minus 1 over r minus 1. So I've got 8. Now once again, I need my r value. So I'm going to take 12 divided by 8 and get 1.5. 12 divided by 8 is 1.5. So my r value is 1.5 to the 25th minus 1 all over parenthesis 1.5 minus 1. Now make sure you know how to run this through your calculator. Use your parentheses correctly. 8 parenthesis 1.5 caret 25 minus 1 parenthesis divided by another parenthesis 1.5 minus 1. Remember, you can always simplify that bottom in your head if you want. So there's what we got going on this one, except for I typed it in wrong. So let's go 8 parenthesis. I typed in 15 by accident instead of 1.5 minus 1 divided by parenthesis 1.5 minus 1. We'll see if this looks a little bit better. And there's the number you should get, 404,002. Now be careful here. Since this terminates, I'm going to write all the decimals. If you decide to round that to 0.7, you will need an approximately sign in front of there. So I'm going to call it equal 404,002.6927. So guys, what I've done there is I've just reviewed everything that we've done within the sequence and series unit. I did a little bit before, did a little bit now. You'll now have some time to work, and then we'll quiz you the last 15 minutes of the hour. Good luck.